probability, and we'll start by talking about the difference between theoretical and experimental probability. So probability is a numerical event from 0 to 1 that measures the likelihood of an event. So the probability of flipping a coin and getting heads is 1/2. So probability is a number that is assigned to an event to show how likely it is to happen. Now, the big words for today are theoretical versus experimental. And theoretical is all in theory, right? It's the likelihood an event occurs just based on the math. It's not based on anything that actually happened, but it's just based on what we think should happen given the math. So if we talk about a 6-sided die and we roll it, what's the probability that we can roll a multiple of 3? Well, when thinking mathematically, we would list out all the options and circle the ones that are successes. So the probability of this happening is 2 out of 6, or 1/3, or 33.3%, or 0.333. All of those are acceptable ways to write probability, and I will keep to that unless I specifically say it in the directions I want a certain way. If you don't know, any of those 3 forms will be fine. And then same thing with an even number. Well, if these are the 6 numbers and 3 of them are even, then the chance of rolling an even number is 3 out of 6. So this number down here is our total number of outcomes. Okay? And if you don't know the deck of cards with the jack, queen, king, ace, all of that, I'm going to need you to try and learn that for this unit. And it's also, a picture is also available on Schoology of the entire deck. But basically, a deck is made out of diamonds, hearts, spades. That's a pretty bad spade. Spades and clubs. So, and there's 13 cards of each. There's 1 through 10, and then there's the jack, queen, and king. So there's 13 of each of these. Okay? So the probability of getting a diamond would be 13 of those diamonds out of the 52 cards in the deck. Think 52 card pickup. So this is 1/4. And the aces, every suit, every logo, they have an ace, and an ace is a number 1. So it's like, the card would look something like this. And there's just 1 on there. And every suit has 1. So there's 4 aces out of the 52 cards, which is 1 out of 13. And we could say, this is how we represent when we say, what's the probability of drawing an ace? We just put P for probability and then ace. So we could write probability of an ace equals. It's good to give nicknames so you can communicate what you're trying to say. Okay, so if we have a playlist and we have all these different types of songs on it, what's the chance that when we hit play, that we get a lo-fi song? Well, there's 5 lo-fi songs, and in total, how many songs are on this playlist? Is it 30? Let's see. Yep, 30. So 5 out of the 30 songs are lo-fi songs. So when I pick one, it should be a 5 out of 30 chance, which is 1/6, or 16.6%. Probability of not picking a rock song, a success then would be picking anything else. So whether it be a pop song, a lo-fi song, or a hip-hop song, out of the 30, those would all be successes. So we get 2/3 for that, which is about 66.7%. Okay. Now this is interesting. If you're playing Monopoly, you would play with 2 die, or Settlers of Catan, or a lot of other board games. You roll 2 die at the same time. Okay. And each of them have the numbers 1 through 6. So how many outcomes are there? For those, how many different arrangements can we have? Like, for example, we could have a 6 and a 6, or we could have a 5 and a 6, or we could have a 6 and a 5, And those are different because maybe the dice are different colors. Maybe this is a yellow one and this is a green one or orange one. So order matters with this. And because it's 6 and 6, we would just do 6 times 6 is 36 outcomes. And we could write out all the possibilities, and we would write like, okay, 1 and 1, 1 and 2, 1 and 3, 1 and 4, 5, 6. Start over, 2 and 1, 2 and 2. And if you continue all this, you'll have 36 pairs. So to get a 5, you either roll a 1 and a 4, a 2 and a 3, a 3 and a 2, or a 4 and 1. Because out of these 36, order matters. So we have to list every single possible thing. So 4 out of 36 or 1 out of 9 would be the probability. Okay? Now, the other side is the experimental probability. What we've done so far is we've been listing out outcomes, computing sums, looking at the total number of outcomes, doing all of that together, all this math, and that's theoretical. But experimental is using actual data. Okay, so make sure you have those written down, and then I'll do these 2 examples. So it says a quality control inspector samples 500 LCD monitors and finds defects in 3 of them. What's the experimental probability that a monitor selected at random will have a defect? Experimental is going to use this data. So it's going to be 3 defects out of 500, or a 0.6% chance. So a pretty slim chance that you actually pick one out of the 500. Now, so this was a sample, but if the company manufactures 15,240 monitors in a month, how many are likely to have that defect based on these results? So this is huge in stats and probability, is to take a small sample, measure something, and then extend it to the whole population. So if we take 0.6% of the population, the whole sum, we could do that by just doing 3 out of 500 times the total number. And if you do this, you're going to get around 91 defects. Okay, so have a smaller sample, because we can't sit here and count all 15,000 and see how many there are, right? We want to just do a little smaller sample, like 500, count that, and then extend it. As long as it was a good sample that you picked, then you should be totally fine. Okay, so a park has a lot of trees. You select 40 at random. Hopefully it was like truly random. And you determine that 25 are maple trees. What's the experimental probability that a tree that you chose out of that 40 is a maple tree? Well, there were 25 of them. So this would be about 62%. And if we want to extend that, say, to the whole park and estimate how many maple trees are there in the entire park, we would just do 62.5% of all the trees in the park. And you would multiply that as a decimal. You could write it like this. And you get around 336 maple trees. Okay? So thanks for making it to the end. I think this will be worth it for you. Really, the big thing you want to take away from this is the difference between theoretical and experimental.